One of the most unsettling and overlooked aspects of vitamin B12 biology is the paradox of normal blood levels masking deep, progressive neurological injury. It seems counterintuitive, after all. Standard lab results should reflect the body's nutritional status. But in the case of B12, the situation is far more complex, and the hidden danger lies in the gap between what blood tests measure and what the nervous system actually receives. Vitamin B12 in circulation doesn't tell the whole story. Blood tests typically measure total serum B12, a pool that includes both active and inactive forms bound to proteins like transcobalamin and haptocorrin. However, only the fraction of B12 attached to transcobalamin, holotranscobalamin, is biologically active and available for cellular uptake. It is entirely possible, especially in older adults, people with digestive disorders, or those with subtle metabolic issues, to have normal or even elevated total B12 levels while active B12 is deficient. In these cases, what shows up as normal on lab results belies a dangerous cellular famine, where neurons slowly starve of the very nutrient they need to repair and sustain the myelin sheath. Another layer of mystery comes from B12 analogs, molecules structurally similar to cobalamin but metabolically inactive. Some plant-based foods and certain bacterial or fungal contaminants in supplements can provide these analogs, which occupy B12 transport proteins yet fail to participate in methylation reactions. When these inactive forms flood the bloodstream, they can artificially inflate serum B12 levels, giving a false sense of security while the body's methylation cycles stall and neurons remain vulnerable. Even when active B12 is present in adequate amounts, poor cellular uptake can foil its protective role. Genetic variations affecting transcobalamin production or receptor function, autoimmune processes like those seen in pernicious anemia, or subtle inflammatory states in the gut can all impair the delivery of B12 into the cells that need it most, particularly glial cells responsible for maintaining myelin. In these individuals, nerve fibers may begin to demyelinate and degenerate even as their blood work looks deceptively reassuring. This disconnect has powerful clinical implications. Patients can experience early neurological signs: unsteady gait, numbness in fingers and toes, mood disturbances, or cognitive slowing, despite lab reports showing normal B12. Such cases highlight the necessity of a more nuanced approach. Measuring active B12, holotranscobalamin, or metabolic markers like methylmalonic acid, MMA, and homocysteine provides a more reliable window into functional B12 status. Elevated MMA or homocysteine often reveal cellular deficiency even when serum B12 levels appear acceptable. Yet beyond clinical testing, there is a hopeful side to this hidden story. The nervous system's response to B12 repletion can be astonishingly rapid, particularly when caught early. Patients with subtle symptoms often report improved balance, sharper memory, or lifted mood within weeks of restoring active B12. It suggests that the window for reversal is wider than once thought, and even normal B12 results should not dissuade clinicians or individuals from investigating unexplained neurological changes. Ultimately, the enigma of hidden neurological damage despite normal B12 blood levels reminds us of the limitations of conventional testing and the sophistication of our body's nutrient dynamics. It encourages a more vigilant, personalized approach to assessing and supporting brain health, empowering us to protect the very networks that define our thoughts, sensations, and identities.